Hello, today we're going to learn about equivalent fractions. In this picture here we have fraction strips. Notice we have a whole and another whole and another one whole, except each whole is broken into a different amount of pieces. In this whole it's broken into two equal pieces, giving me 1/2 and 1/2. In this whole it's broken into four equal pieces, giving me 1/4, 1/4, 1/4, and 1/4, which all creates one whole when we put those four pieces together. And here my whole is broken into eighths. Notice here I have 1/2, and I'm going to take a look at just this piece here. I see that 1/2 is equal to what's shaded in orange, but what's in orange is 1/4 and 1/4, which is 2/4. Now, even though 1/2 and 2/4 has a different numerator and denominator, they're still the same size and value, which is proving that these fractions are equal, and they are also known as equivalent fractions. Here we have 1/8, 1/8, 1/8, and 1/8. When we put these eighths together, it creates the fraction 4/8. And I notice that 4/8 is also the same size and value as 2/4 and 1/2, showing that 1/2 is equal to 2/4 is equal to 4/8. Or you can say that these three fractions are equivalent. Now here I have fraction strips, which many of you are welcome to use for today's activities. What I like to do about fraction strips is take a look at the fraction that could potentially be given to me. So for example, if I had the fraction 1/3, which I will highlight here, if I had 1/3, which is right here, my goal is to identify what fraction is equivalent to 1/3. So I like to look right here, and I take my pencil or my mouse and I'm going to go down my fraction strips and see what is also equal size. And I notice here this line hits the same value as 1/3. But if I continue to 1/8, notice it does not. So now I have 1/6 and 1/6. So I'm going to also just highlight these 1/6 and 1/6, which notice what I highlighted is the same size as 1/3, which is proving that 1/3 is equal to 1/6 plus 1/6, which is 2/6. So 1/3 is equivalent to 2/6. Notice I did use my fraction strips here to help me with this. Now, if I had 1/2 here, notice just like my previous problem, I can draw my line going down and I see that it hits right here, which here I have 1/4 and 1/4, which is 2/4, which we proved that that was equivalent to 1/2. Now, as I continue, I notice I'm also hitting sixths. So what would be equivalent to 1/2 here? Well, I see that I have 1/6, 1/6, and 1/6, which gives me 3/6, which is also equivalent to 1/2. And if I continue on, I have 4/8 here that is also the same size and value as 1/2. So for today's activities, you are welcome to use fraction strips as one method to help you identify equivalent fractions. You can also use a number line to help you identify equivalent fractions. Now, what I'm going to first do when I see a number line is label what is given to me. My goal here is to determine what values go in this missing box. And by looking at the number lines, I notice that these boxes are right on top of each other. Both number lines are labeled from 0 to 1, and that's showing me that these boxes and these fractions I will determine will be equivalent. So the first thing I'm going to do is first notice that my two whole numbers from the left and the right side of this number line are 0 and 1. So I need to determine what fractions go between 0 and 1. First thing I'm going to do is count how many equal parts this number line is already broken into. So here I have 1, 2, 3, 4, 5, and 6. That means I'm going to have 6 equal pieces. So I start here, and really 0 is also equivalent to 0/6. And here I have 1/6, 2/6, and now here I have 3/6, and that's my missing value, 4/6, 5/6, And now I notice here they wrote 1, but we know 1 is also equivalent to 6/6 because 6 divided by 6 is 1. So notice here we numbered my number line. We labeled everything. And by labeling everything, that helped me to determine what my missing value was, which is 3/6. Now I'm going to take a look at this number line. The fraction will also lie between the whole numbers 0 and 1. But I notice in this number line it's only broken into 2 equal pieces. I have one piece and here's my second piece. So here I have 0 halves, which is also equivalent to 0. And then I have 1/2, and 1 is also equivalent to 2 halves. So now my missing value here is 1/2 and here is 3/6. So if you have a number line today and it's asking you to find that missing value, you can simply label it and then hopefully that will help you to determine the missing value. What I like about this number line is it's showing me that 3/6 is equivalent to 1/2. You are welcome at any time to draw number lines today to also help you determine equivalent fractions. Now, my last method that you might find useful as well for today is to look at what the fraction is given to you. So we have 1/2 equals something, but we know that something is going to have a denominator of 6. So what we're going to do is look at what was given to us. If I see that we have 2 times something gave me 6, well, 2 times 3 is 6. But what's really great about equivalent fractions, if you do an operation to your denominator, such as multiplication or division, then you need to do that to your numerator. So that means if I multiply my denominator by 3, I need to multiply my numerator by 3 as well. So now I have 1 times 3, which equals 3. And then 2 times 3 was 6. This is proving that 1/2 is equivalent to 3/6. And from the previous problems we had, we actually looked at fraction strips, and that also proved that 1/2 is equivalent to 3/6. Now in this problem here, we have 2/7. We need to figure out what fraction is going to be equivalent to 2/7. But in this case here, my numerator is 2 and my new numerator is going to be 10. So 2 times what number gets me to 10? And I know it's multiplication because my numbers are getting larger. I'm going from 2 to 10. If my numbers were getting smaller, let's say going from 10 to 2, then I would be dividing. But in this situation, we are multiplying. So 2 times what number gives me 10? Well, 2 times 5 equals 10. Now, if I multiply my numerator by 5, I do the same to my denominator. So now 7 times 5 is 35. So the answer to this problem is 10/35. And my new denominator is 35. Notice here, 2/7 is equivalent to 10/35. In this problem here, we have 1/6. Our goal is to determine 6 times what number gets me to 48. So 6 times 8 is 48. So if I multiply my denominator by 8, I do the same to my numerator. So 1 times 8 is also 8. Now 8/48 is equivalent to 1/6. Now it's important to recognize that these are equivalent fractions because sometimes you might want to represent them in the smallest form, or sometimes you might want to leave it as 8/48. But depending on what's given to you, it's important to recognize that these values are the same. So now here we have 2/9. We are also given 20 as my new numerator. So I need to take a look at 2. I see 2 times something gives me 20. Well, 2 times 10 is 20. So if I multiply my numerator by 10, I do the same to my denominator. So 9 times 10 is 90. So that's proving that 2/9 is equivalent to 20/90. Now you are welcome to do this on the side of your paper and use scrap paper to help you identify the equivalent fractions. You are also welcome to use a number line or fraction strips to help you when determining if fractions are equivalent and helping you find and identify equivalent fractions during today's activities. As always, feel free to refer back to this video at any time to help you.